All right, let's do a fun exercise to show you that you've actually just become a better engineer. Let's have a situation. Let's say you're working at Twitter, and I hope everybody knows Twitter here. If you're working at Twitter and your boss asked you to build a feature, perhaps a feature that allows anybody to click a button next to their name and retrieve their most recent tweet and their oldest tweet. So that is their very first tweet and their very latest tweet. Based on Big O notation and what we know about Big O notation, what can we assume about this problem? Well, without coding anything, we know that we have to find first and then find nth, or whatever the last item is. Now, we don't know how the tweets are stored in our database or whichever way Twitter organizes these things. But based on how they are stored, we might be able to just grab, let's say the tweets were in an array. So let's say const array, and we'll have an array of tweets. And let's just say we have 3 tweets here. There you go. Just 3 simple tweets. We'll say that this one is the oldest and this one is the most recent. If we have an array here, we know that it's going to take us, if the tweets are stored in an array, it's going to take us, well, if we go array 0, we get the oldest tweet. And if we go array.length -1, we get the 3 minus 1, so that is 2. So that is 0, 1, 2. This is going to be 2. We're going to get Teddy, the most recent tweet. And because of the way arrays work, we know that both of these operations will be O one time. And this one will also be O1, or constant time. So a total of O2 operation, but we, again, use our rule book and simplify it to constant time. So that's great. We build a nice little simple Twitter application and we can get that information very easily. But now our boss comes back to us and say, hey, I want you to compare the dates of tweets. So I want you to look at every tweet. Now, within each array, there's an object. With each tweet, now we have, and this person does not tweet a lot, 3 tweets in 6 years, but now we have to compare each tweet with all the other tweets and compare their dates. What is the big O of this operation? Well, because we're comparing each item in the array with the other, this should sound familiar, we're doing nested loops. So this is going to take O and square time, at least with what we know right now. So we know that this is going to take a lot. And if it's a person that has a lot of tweets, a lot of inputs in the array, this operation might cost us a lot of money at Twitter. So you might want to tell your boss, we might have an issue here. We might need to do something else. Perhaps store this information in a better format or do something different with our program in order to avoid something that might be inefficient. It might be expensive for the company. And just by thinking like this now, you have this ability to think long-term, think scalable code. By the way, as a fun one, what happens if I ask you, what is the operation and what's going to cost us if I have a string and I do dot length here? In JavaScript, that just means what is the length of our string? that is 20, that means we have 20 items in the string. What do you think the big O notation of this is? And this is a bit of a trick question and something that you might get asked in an interview, because the answer to this is depends. It depends on the language that you're working with. We need to know how the method works on the string here, and that's built into JavaScript. And you'll have a different built-in method for your language. Based on how the language was built, this .length might go one by one and iterate over each letter and count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way until 20. But JavaScript actually has .length property built in to each string. So for JavaScript, this .length property is just a simple lookup. It's not a function. We're not running this function to calculate things. Instead, it's simply a property of an object. And because of that, and again, if you're not super familiar with JavaScript, this may be a little bit confusing, but don't stress out. The idea is that this operation in JavaScript is O constant time. But without knowing how your language works, you don't know how this property might work. How perhaps if you had a method, how that might work. But now you have a powerful foundation, powerful pillar to start thinking about code in a different way. Start looking at space and time as something that are valuable to us as engineers, as resources that we must be careful. We don't have infinite amount of resources. We have to be careful when we code how we use up these resources. And that alone makes you a better engineer. I'll see you in the next video. Bye-bye.